Hi, welcome to the first episode of how to, I don't know what to call it. So yeah, today we're obviously from the title we're going to learn how to shower. So you might say I've been showering all my life. See, this is the shower. The water's coming down, and I'm here cleaning myself. So I think I'm pretty sure I know how to shower. Well, you're wrong. Turns out you know nothing about it. Why do the shampoo bottles keep falling down? Because you're doing it wrong. So today, be glad because I'm going to teach you how it's done. So first, before going to shower, you see these. This is the cold water, and this is hot water. So you need to find the perfect balance, and that's what we're here to talk about. So there's a formula to this that I'll gladly share it with you guys. So it's hold on a second. So it's T equals V N. And we'll get to these. We'll get to what these are. Okay, so this is a shower. You want to wash yourself, and let's say cold water is coming out of it. So first, what you need to do, this is necessary, use your head. Everywhere, use your head. See, so first you go in and examine the temperature, get a feel for the water with your head. If it's hot or cold, you jump back. That's where velocity comes from. So this, check. What about these two? So this is wavelength, this is lambda. Wavelength equals wavelength. So if the water is hot, you will release a high pitch sound. So see, this is like this. It's going to be like this. Lambda will be small. It's going to be small. But if it's cold water, you're going to release a lower pitch. These are god damn it. These are relative. Okay, so lambda cold relative is lambda cold. God damn it. Okay, so lambda cold is bigger in relation to lambda hot. Why? Because lower pitch sounds are like this. So you might want, so this is check when you want, what's this n here? N is the number of pulses, and most likely in most situations n hot is smaller than n cold. Why is that? Well, everywhere, when you're experiencing cold water, for example, being poured on you, you go see, one pulse, 2 pulse, 3 pulse. See, so yeah, these are all checks. So now we know what these are. And this, you might be wondering, well, what is this? Is it Celsius, Kelvin, Fahrenheit? The other one, I don't know what it is called. Well, none of these. This is a new thing. This is temporal. Okay, temporal. Yeah, we'll just put that on here. Okay, this is temporal. Okay, so now we're going to teach you how to use this formula. Okay, so let's say that this person, will use a gray water, because this is not gray water, this is just to show that the water, we don't know if it's cold or hot. And this extremely handsome man here uses his head, so and he flings back the velocity of 12. So we have V is equal to 12. This is 2 meters per second, and the wavelength of his scream is going to be 0.5 meters, and so he screams for 1 minute. Okay, if the question doesn't tell you how long they scream, we just assume it's 1 t equals to 1 min, and every every half a second. Yeah, and we got a pulse. Okay, so what's temporal? What's the temporal here? So first let's choose a different color to, okay, so we'll use this color. So we write off, actually this is too bright, you might not see it, so yeah, we'll use this one. So we got the equation, we write it down, and lambda. So we got these. What about, we don't know the n, so in order to calculate n, so we know that it's 1 minute, it equals to what? 60 seconds. Oh, we are so smart. And every half a second we get a pulse, so this means we need 60 times 2, n equals 60 times 2, which is obviously 120. So now we get these, the temporal equals 12 divided by 120 times half, this is 0, and it will be 12 on 60, which is going to be 0.2, I think. Let's calculate this. 60 divided by, okay, 12 divided by 60, yes, it's 0.2. So now we know the temporal of this is TP, temporal is 0.2, but now we need to identify it. Is it cold or is it hot? Okay, and I'll explain it to you. Let's delete this, and remember temporal is 0.2. So we got our temporal here, it's equal 0.2 TP, and we want to know, is it hot or cold? So let me explain this to you. Let's write our formula here. We get velocity and lambda. So remember this, okay? V cold is going to be always smaller than V hot, because for some reason you fling back faster if you're experiencing hot water. And we know that if it's hot water, you produce a high-pitched sound, which the wavelengths of a high-pitched sound are smaller than the wavelengths of a low-pitched sound. So lambda hot is smaller than lambda cold, and I've told you that n cold is bigger than n hot. So what do these mean? These mean that if it's cold water, the denominator will be bigger, and thus temporal will be smaller. So we got temporal of hot bigger than temporal of cold. So now we got 0.2 here. Where do we put it? Well, remember, I don't know if I said this to you or not, but temporal, if temporal is 0, then we can bath. This is temporal mid. So why? Because if it's the perfect temperature, then we won't fling back, we'll just stay there and wash ourselves. Hence V equals 0 and temporal equals 0. And mid, it comes between the two. So T hot, temporal of hot, greater than temporal of mid, greater than temporal of cold. So get hot and greater than 0 greater than cold, and we got what we get 0.2. So, and 0.2 is greater than 0. It's bigger than 0. Hence, our water was hot. Thank you for watching this video, and this is how it's done.